Microsoft Excel is a widely used tool for analyzing data. That's why so many programs support the reading and writing of Excel files. And MATLAB does too, with two built-in functions called XLSRead and XLSWrite. Here we see a spreadsheet open in Excel. It contains monthly weather data for Nashville, Tennessee. As you can see, it contains not only numerical data, but also various labels for month names and weather data such as temperature and precipitation. Assuming this data is saved in a file called nashvilleclimate.xlsx, we can easily load it into MATLAB. We do that by calling the XLSRead function with three output arguments, num, txt, and raw. The only input argument here is a string. It's the name of the file. You may be wondering, why are there three different outputs? Well, MATLAB's nice enough to separate the numbers from the text for us. Numbers in the Excel file are collected and returned in the first output argument. Text is returned in the second output argument. And finally, the third argument contains everything. Depending on what you need, you can use any or all of these outputs. Let's look at the first argument, num. Num is a matrix of doubles. No surprise there. But an interesting aspect of num is its size, which is smaller than the size of the spreadsheet. What MATLAB does here is find the smallest rectangle of cells in the spreadsheet that contains all the numbers. That rectangle may be only a subset of all the cells in the spreadsheet, as it is here in this example. In this case, it makes up 14 rows and 3 columns, so that's the size of num. But there's a hitch with this plan. MATLAB picks up all the cells from this rectangular area, and some of those cells may not contain numerical data. Like this 2x3 non-numerical array in the middle of our example, it contains 3 empty cells and 3 cells with text, none of which is numerical data. For these cells, MATLAB assigns a special value in the output argument, NaN, which means not a number. So in this example, it puts a 2x3 array of NaN, or nans, in the middle of the output argument. Text is returned in a similar fashion. This time, the smallest rectangular area is selected that contains all the text cells. The type of this second output argument, txt, is a cell array instead of an array of characters. That's the only way to return text, because there can be different numbers of characters in the cells, so it's not possible to return it as a rectangular character array. Now numbers turn into empty strings. But what about those strange-looking entries, 1 by 30 char and 1 by 40 char at the top left? Well, they correspond to strings that are simply too long to print conveniently in the command window. So MATLAB just prints the type, the dimensions plus the element type. But don't worry, all those data are there in those cells. Finally, if we need everything from the spreadsheet in one array, we get that in the third argument. It's a cell array that's the union of the previous 2 arrays. All the data are here in one cell array containing doubles and strings. And this time, it's the smallest rectangle that contains everything in the spreadsheet. Okay, let's try this out in MATLAB. Well, it's easy to implement pretty much anything in PowerPoint. Let me show you that it's really this easy to handle Excel files in MATLAB. First, let's make sure we have the data we need in this directory. What I want is this Nashville climate data. There it is right there. It's an Excel file with the ending XLSX here. So, first thing I want to do is just read the numbers in the file. To do that, we'll give it just one output argument instead of all 3. And there's our function. Gee, that's a lot to type, and I'm lazy, so what I'm going to do is just copy and paste. There's all our data. How cool is that? A single command, and we have all the numeric data in the Excel spreadsheet loaded into a MATLAB variable. If we want both numerical and textual data, we can do this. There are the numbers, there are the strings, with these empty strings where there are no strings. So that's how you get both of them. If you're not interested in the numerical data at all and you just want the textual data, you can do that too. There's a new syntax we haven't mentioned before that allows you to skip an output argument. Looks like this. Instead of temps here, I put a tilde and a comma. You got to have the comma if you're going to use the tilde. And so this time, we didn't get the numerical data, just the second set of data. And this works with any function that has multiple output arguments. And if all we care about is the entire file, that last argument, we can do this. 2 tildes. We don't want the numerical, we don't want the text, we want everything. And there's everything in that format where not a number is an empty cell, and here's the numbers over here, and here's strings, and so on. Often we want to read from a specified area within an Excel workbook. Here's how to do that. Here we read the data from just a single cell. The second argument here specifies the sheet. You can use the number just like I did here, 1 for the first sheet, 2 for the second, and so on. Or you can specify the name of the sheet using a string in the second argument. The third argument is the name of the cell. And you can specify an area using this syntax. Here we use Excel's own notation in the third argument for a rectangle of cells. Note that that colon right here is not MATLAB's colon operator, it's just a character in the string. It indicates that D15 is the upper left-hand corner of the rectangular array we want, and E17 is the lower right-hand corner. We can also write data to Excel files using the XLS write function. At least on Windows we can. On a Mac, MATLAB provides a somewhat limited alternative. XLS write writes text files instead of Excel files. Only numeric arrays can be written, and each row is written on a separate line, and the numbers on a row are separated by commas. This format, which is called the comma separated value format, or CSV, is written and read by many applications, including Excel. Because of this limitation, we're not going to cover XLS write here, but the function is just as easy to use as the XLS read function. Only thing to keep in mind is that you can overwrite the contents of an existing file. You won't get any warning. The good news, however, is that you only modify the cells that you actually write. The other cells will not be affected. Try Help XLS Write or read the book for more details.